Okay, the first thing you need to do in order to get the weight and balance working correctly is create an image file. This will eventually be called wb.miff, and it needs to be sized correctly so that it fits on the screen. Second thing you need to do is create the weight and balance definitions file. This is where you put all your weight and balance envelope limitations in and your loading stations, and you do that in the EFIS simulator program downloaded from their website. Right, let's start by searching the internet for a suitable image file that we can use for our weight and balance calculator. So I'm going to type in RV7 3 view, always a good place to start. Lots of 3 views on the internet, and you might be able to drag one of them off which is suitable for your aircraft. My recommendation would be, if you have an aircraft which has, for example, left and right wing tanks, you're probably best off getting a top view. If you have an aircraft which just has fuselage tanks, either a top view or a side view would be fine. So we're going to take off a top view of an RV7 from the excellent Vans Air Force website. Flyvans.com's very kindly put one on here for us, and we'll use that image and save it as a JPG just to our desktop. I'm just going to call it a file name that I'm going to be able to recognise easily, rv7w&b.jpg. And we'll keep that on our desktop. A quick bit of information for Mac users. If you're a Mac user, you can certainly still do all this MGL stuff, even though MGL software is designed to only run on Windows, by using Parallels Desktop. I use Parallels Desktop, Windows 10's loaded onto that, and it works fine. It's actually quite easy to swap between desktops, and here's the Windows desktop. It was that simple. And I can drag the image file from my Mac desktop onto my Windows desktop. That's what I want to do because I want to do the editing in Windows, and we need to do the conversions for these files in Windows, and of course we can only run the simulator program in Windows as well. So there's my file. The next thing I need to do is make sure that I have the Miff converter. There's a bitmap to Miff conversion utility. It's available on the MGL website, the South African one, not the American one. And if you go to downloads here, tools and applications, you'll see about halfway down the page there's a program called Enigma BMP to MIF.exe. That's the one we want to download, and that will convert bitmap images to Miff images. The Miff format is the format that is readable by the MGL EFIS. Note there's a line here which says weight and balance backdrops are 320 by 140 pixels. Not strictly true for the latest EFIS displays. For the latest ones you can have up to 500 by 220 pixels, and that'll still display in the available screen real estate. Right, the next step, let's get this image cropped and sized in a way that's going to display on our weight and balance screen. So I'm going to use Paint 3D here in Windows, and I've only just started using this recently. You can use any image editor that you're comfortable with. I'm going to go to Canvas, and that'll give me on the right hand side there some information about the current image size. It's still a JPG format, remember. We're going to reformat it and rename it later on. So I'm going to resize the image with Canvas, and I'm going to lock the aspect ratio so that the image doesn't squish up and look rather silly. And I'm going to put in 500 pixels width and see what that gives me when it resizes it for height. So the height obviously is not going to work here. That's too big. We can only have 220 maximum height for the weight and balance screen. That's okay. I've shrunk the image, so I'm going to untick the lock aspect ratio and resize image. And now I'm going to type in 220 here, and that'll have the effect of cropping the image in a way that will display just nicely on the weight and balance screen in exactly 500 by 220. Now there are a number of different ways you can crop and resize images. My suggestion, if you're not familiar with using these types of image editing programs, is maybe ask your kids, or maybe just have a play around and see how you go. But that's the crux of it. There are a few different ways of doing it. We want to crop it and resize it to something that's a maximum of 500 wide by 220 high. Now we're going to save it, and we need to save it as a bitmap. So I'm going to select Save As, Image. It will come up with Save As Type. I'm going to select that and change it to bitmap. It needs to be a bitmap to start with to be converted by the MGL bitmap to Miff conversion utility. No thanks, Microsoft. So now the image is saved in the same name that I originally created it, but as a bitmap file. I'm not going to bother saving the original JPG. What I'll do is I'll just relocate the bitmap image, and that's something we can now plug in to the conversion utility to get it in a format that's readable by the EFIS. Now I'm going to start up the bitmap to Miff converter. It just starts with a blank page there. I'm going to press Load Image, find my bitmap file, select that, open, and it'll show it on the display there. I can check the width and height. 500 by 220 is the maximum for the weight and balance display. I'm going to process it. It tells me where it's stored the Miff file, and I'll exit out of that. And what it will have done now is it will have stored it on my desktop. So there I have the file rv7wnb.miff. And it should be 500 by 220 pixels. You can't open that. Miff is only readable by the EFIS itself. Right, let's go to the simulator now and really make things start to happen. So I've opened up the simulator program, and I'm going to go up to the file manager, the built-in file manager. And on the left side, I'll select desktop, which is my desktop. On the right side is project, and I'll select my project. Never mind that the image isn't the right image of the aircraft. I'm just doing this for illustration. I want to go to the other folder in your project, which will be in the flash directory. And now over here on the left side, I want to find that RV7 weight and balance Miff file, and I want to click and drag it into the other folder of the project that you're working on in the simulator. There it is, rv7wmb.miff, and it's located in the other folder. And we're not quite finished yet. We need to rename that. The reason is that the software will only recognise a file which is called wb.miff, and it won't recognise any other file name. So we'll just amend that file name to wb.miff. Right, now let's get out of that now, and we're going to go up to the top menu, weight and balance, define weight and balance. You'll see here our Miff image has loaded successfully. And the note underneath says, please limit image height and width to 500 by 220. That's in pixels, and that's where those numbers come from. That is simply to display the image in the available real estate, both in the definition form here and also on the real EFIS. On the top left, we've got some data. You can give it a name. We have things like empty weight, unit selection, metric or imperial, specific weight of fuel is a default value, but it can be changed, and location of CNG empty from the datum point. All of that information should be in your operating handbook or manufacturer's notes. And also in your operating handbook or manufacturer's notes will be the defining points on the weight and balance envelope. That's down the bottom left here. That involves maximum and minimum weights and the moment arms defining the centre of gravity limitations. So you can see, starting at the bottom lower left corner of the weight and balance envelope there, I'm just going to zero out some of these numbers just to simplify the envelope while we look at it. But the first corner of the envelope there is 544 kilos and an arm of 213.4 centimetres. That's there. And then the next defining point is 748 kilos, 213.4 centimetres again. So the 213.4 will be the most forward limit of the centre of gravity. And then the envelope just changes shape slightly, as some of them do. Some envelopes will just be a square. Others will have different defining points on them, and we just work through those points straight off your approved data, weight and balance data for your aircraft. We eventually get over to the most aft centre of gravity at the maximum weight and minimum weights. Once we've put all those in, we have a centre of gravity envelope. And don't forget to just double check you've got those units right. It's worth noting that in metrics, some weight and balance definitions are in millimetres aft of the datum, but the input here has to be in centimetres, and you also need one decimal point, but weights must be whole numbers. Right, so let's look at putting these station definitions in. Two main types of station definition, and that is normal and fuel. Normal being a person or a baggage area, and fuel being either a manual entry down the bottom there. You see fuel entry. That just simply puts a button in where you can manually input a fuel figure, and it'll give you the weight and centre of gravity calculations. And you can see a whole list of other types of fuel entry, and they're sensor entries. So they'll display what your sensor is sending to the RDAC. And it's not documented all that well what these particular fuel entries are, but fuel 1 and 2 is fairly self-explanatory. The number in the brackets, I believe, is the RDAC number. So you'll see that they go from 1 through to 4, because you can have up to 4 RDACs. And the C1, C2, I'm pretty certain, are calculated, or your virtual fuel tanks, because remember, for each RDAC you can have fuel 1, fuel 2, you can have virtual tank 1 and 2. So that's what I'm pretty certain those C1 and C2 numbers refer to. And so that's repeated from 1 through to 4 for up to 4 RDAC units. So I think for most aircraft you'd probably either have fuel 1 and 2, just on the one single RDAC, which is the top 2 entries, and that will give you the sensed fuel levels. Or if you want to do a manual input like I do on my aircraft, because I don't have fuel tank sensors, you can just go right down the bottom and just put fuel entry, which will just give you a plain button where you can manually input that fuel. So we're just going to give it a name, pilot. Let's start with the pilot. There are 3 things we need to put in. A button position. That's the button you'll press to input the data there. Then we need to put the name somewhere appropriate, and then the data entry position. So you can see I'm moving the button across here. Just has a red button It's an X coordinate and a Y coordinate, fairly simple. They're just in pixels across and down on the screen. And we can just do either coarse movements by typing in a number, or by using the up and down arrows we can do fine movements and get this button exactly where we want it. So there it is over the pilot's seat approximately. Now we want to put the name, so that's basically a tag attached to that button, so we actually know what data we have to put in there. And I'll shift that around a bit. I'm going to place it next to the button. I think I'll just put it to the left of it. You can put it wherever you like, whatever looks most eye-pleasing to you. And then we need to put the data entry position. The data entry is the actual number that will go in there. So, i.e., in this case, the weight of the pilot. So when you touch that red button in the EFIS, it will come up with a keyboard that you can put the numbers in, and you can enter the pilot weight, and it will put that into the weight and balance calculations. Same process occurs for every station that you define here, and don't forget, obviously, we need the moment arm of that station. That'll be in your weight and balance data from your operations manual. So we need to put in a moment arm, and then we just repeat that process for each station, set up all our buttons and all the labels or names attached to those buttons and the data entry positions. So I'll just fast forward this a bit just to save a little bit of time here, and you'll see that I'll put in the pilot, I'll put in the passenger on the other side, and I'll put in a left and right wing tank fuel, sensor fuel. So it'll just be a fuel 1 and a fuel 2 as sensed by the fuel tank sensors themselves. All right, you can sit back and watch this in fast forward, putting in the other stations, moving the buttons across, moving the names across, and locating the data entry positions as required. And once all of this is finished, you'll find that the simulator has automatically created a definitions file, and it's called wb.def, and that'll be located in the other folder along with the wb.miff file. We'll have a look at that shortly, and the only remaining thing to do after that is to copy those two files onto your micro SD card and load them into your real EFIS. Right, here we are back in the simulator program. I'm going to go back into the file manager, and you can see now in the other folder we've got the wb.def along with our wb.miff, which we had loaded previously. So I'll get out of that. And what I need to do now is, the weight and balance icon would normally be here, but I simply need to reboot the program to get this to take effect. So I'll go back into the simulator program, restart it, and now my weight and balance icon is displayed up there. I'll push that, and there's my weight and balance diagram with the fields I've put in. The right wing and left wing fuel, that's the sensed fuel if you have fuel tank sensors. I can click on the pilot icon, I can put in a weight there, press enter, and my CFG indications will change accordingly on the chart. I can do the same for the passenger. Press enter, and again it changes. And if I refuel and it senses a different fuel, that will automatically change as well. Right, let's get this thing loaded into our EFIS. I'm going to go to the file manager in the simulator program. And on the left there, I've put a USB stick in there, but you'll need an adapter, a USB adapter, or some method of putting your micro SD card in there. On the right, I'm going to go into the other folder, select the wb.def wb.def and the wb.miff files. I'm going to drag them across to what would be a micro SD card in your computer and copy them across, and you would see them here copied across to the card. And that's all we need to do in preparation to get them into the actual EFIS in your aircraft. I'm going to demonstrate a real weight and balance page. This is my actual weight and balance page for my pits. And here you can see that you can put a colour image in if you want a colour image. That's no problem. You can see I've got fuel stations here for the wing and the main tank. And if I put some different numbers in, you'll see the green cross marking the current centre of gravity will change. I change this main tank fuel that says 100 at the moment. This is in litres, remember, so 136 is full, so I'm going to put 136 in. And note that it doesn't actually say 136. What it's done is it's applied the specific gravity and changed it to 98, and that is kilograms. Remember here we had specific weight of fuel, 0.72, that's for avgas. So it has multiplied the litre quantity by the specific weight and come up with a kilogram figure. Let's change the baggage and see what that does. 20 kilos is the maximum we can put in there. Let's move the centre of gravity slightly aft, which we expect. We'll put a passenger in, let's say 75 kilograms. Moved the centre of gravity much further aft, but it's still within limitations. We've got the pilot there already, we've got the bags, and we can see that we're within the envelope, we're below the maximum takeoff weight, and we're inside the aft centre of gravity limit. So we are good to go. That's pretty much how it's done. All right, I've taken my micro SD card. I'm at the hangar. I'm going to switch my EFIS on. There's my micro SD card. I'll just insert that into the slot. And I'm going to press menu. Come across to the display here. I'm going to press install tasks. There's a few things we can do there. First, I'm going to put some new screen files in, which I just happened to do the other day. That'll install them automatically in the correct folder, and now I'm going to do the weight and balance. Install weight and balance files. I'll press that, and it's installed those two files into my EFIS display. I'll press done a couple of times, and now I'll press weight and balance, and there is my image with all the stations in the right spot. And that's how it's done. It's all set up in your actual EFIS display now.